come to these meetings. You're always very welcome to be here. And some people who are coming back, having joined a while ago, we are very happy to see you here. My name is Paula Andrea Martinez. I am the Art Ladies Brisbane founder and co-host. And today I have the pleasure to introduce our speaker of today, Simi Namda. Simi is well-experienced data scientist who's joining us today. She has experience working in higher education industry and also in the Department of Computer Science at the University of Botswana as a teaching assistant since 2016. She will demonstrate her ability to talk about technology, in this case, many packages from R that are useful for data cleaning. She has a master's in science and computer information systems, and her research work is authorship identification. She also has experience in digital text forensics and cyclometry. And prior to that, she was a business analyst at the Gauteng Department of Education, working on data management and business intelligence in South Africa. And she has a bachelor degree in business information systems and is due to complete a postgraduate diploma in education. And she is based in Gaborone in Botswana and is here today to present our packages for data cleaning. Please join me in welcoming Simi. Over to you. Thank you.
Thanks, Paula. Thank you for the introduction and welcome to everyone. Excuse me. I also like to say hello to Valentine. It's nice to finally meet you. And the other, I don't know if Catherine is here, but it's nice to see you girls. And welcome to the presentation to our packages for data cleaning. And I also like to thank Our Ladies Brisbane for co-hosting with us. So we're going to go through who I am. We're going to also talk about the messy to tidy data. And we're also going to go through the poll just popped up. I'm just going to remove it. Okay. And we're also going to go through the R packages used for data cleaning. And as Paula said, we're going to go through an interactive demo together. I hope you have your Art Studio open and we're going to go through the scripts line by line. So I'd really want to extend a big thank you to Paula. We've been talking for past few months. It's good to meet you. Finally, also nice to meet the other Our Ladies Brisbane team, Catherine and Valentine. I don't remember the others. I'm so sorry for that. And I also like to extend a thank you to the Computer Society of Botswana, where the Our Ladies Gaborone and we're actually associated with Computer Society of Botswana, and we're working together, working with other colleges and schools outside of the capital city. And also like to say hello and welcome to the Our Ladies Gaborone team who are here. So I'm Simisani Ndaba. I'm a member of the Our Ladies Gaborone, which started last year in September. So we're fairly new. As Paula said, I'm a teaching assistant. I have been since 2016 at the Department of Computer Science in Gaborone, that's the capital city of Botswana. I did an MSc in Computer Information Systems. Well, actually, my first degree was in business. Then I had to move to computer science because my business faculty didn't have the postgraduate at the time. So I moved to computer science and I continued from computer science, and I've been growing from there. You can actually follow Our Ladies Gaborone on Twitter, and you can also personally follow me at Simisani at 10, but I'm not very active in my own profile. I'm mostly active in Our Ladies Gaborone. I like interacting with other people at a professional level. You can also contact me directly at simisani.ndaba013@gmail.com. In the future, if you want to talk about any future work that you want to get involved in, or you want to work somehow with the computer society, with the computer science department at the University of Botswana. So I just want to talk about where I'm from a little bit. As you can see there, the red dot is Botswana. It's right next to South Africa. We're the northern neighbors of South Africa. I don't know if any of you have heard of South Africa. We're landlocked, Botswana is a landlocked country. So we're in between 1, 2, 3, 4, 5, like 1, 2, 3, 4, 5 countries. So we don't have the ocean, we don't have the seas, we just have lakes, and we have our deltas and our swamps, that which we're known for. As you can see here, you can go for game drives or safaris, as people overseas like to call them. You can see our palms and our natural wildlife, which are elephants. We have very wild animals, we wouldn't say very wild animals, but wild animals like giraffes and tigers, which you can mostly find in the northern part of the country. I'm actually from the southern part, which is Gaborone. It's mostly a desert country, so it's very dry and it's hot all the time. We're also known for our diamonds. I think Botswana is one of the largest exportation of diamonds in the world. I think it's also, Russia is also among the largest exportation of diamonds. Meghan Markle, actually, her engagement ring and her wedding ring is actually a diamond from Botswana. I think it's from the northern part. And they actually like visiting the northern part because it's a tourist country where people like to come and see the swamps and Okavango. And there was also a recent study, it wasn't too long ago, was it 2 years ago, that the DNA evidence shows that mankind started in Botswana. So everybody here, every participant here is originally from Botswana. So you can come home when you want to, like visit or want to stay in the future. So on to the presentation for the day. We're talking about data cleaning. So data preparation is not objective and hard to think of it in that way. It's not like a one size fits all. You can think of it as when you're trying to renovate a house, you can have two kinds of houses. You have a double story and you have a mansion. You can't use the same blueprint because they don't come from the same blueprint. You can't use the same architecture and you can't use the same material because they're both very different. You have to work on them separately in order to get what you want. So you have to think from the perspective of the problem you want to solve and try a few different representations, as in the data structure, data organizations for facilitation, as well as the data analysis you want to set out to perform in order to analyze your data. So there was a study a few years ago, I think it was from Crowdflower or Kaggle. It stated that 80% of data cleaning, 80% of your project work was based on data cleaning, whereas the rest of the 20% was based on modeling and visualization and result distribution, which makes sense because when you look at the data analysis illustration, you have your import, and then
says $9 pizzas.
So sorry, was that a question?
No, an interruption. You can continue.
Oh, okay. Oh, all right. Then when you think of the illustration, you have your importation, and most of the work is on transformation, modeling, and visualization, and then you have your dissemination. So it does make sense that most of the time you'll be doing your data cleaning, which is iterative, as in it's repetitive, and you have to do it all the time. Once you've got your data structure, you have to change it again so it can meet another need, it can meet another standard that you're trying to perform. So the data cleaning includes your exploration of the data, your visualization, and fixing errors. So those errors that you're trying to fix, you have to fix the structural errors, you have to filter unwanted outliers, you have to handle missing data, and you also have to look at whether the data set meets validation rules, as in, are they appropriate rules? Are they following some cardinal rule? Are they trends that you can find? And does it make sense? And do you also have duplicates? So in order for you to meet those standards, there's some tasks for data analysis. You have manipulation, where you can filter, order, and aggregate. You have visualization, which could be helpful to summarize the tabulation and for data exploration. And you have your modeling. So it's actually quite a coincidence, because when we were picking the day, we didn't realize that the 25th was actually a Tuesday. And in the R community, it's Tidy Tuesday. So happy Tidy Tuesday, everyone. So for those of you who don't know, Tidy Tuesday is a weekly event where they post on Twitter, or I don't know if it's on online, but they do have a GitHub where they upload a data set where you can work on your data wrangling and your data visualization, and you post it on Tuesdays. So everybody gets to see what everyone has been working on. So it's actually a very fun event for you, and it's actually good for you to build your profile. Hi, Kara, how are you doing? I see you over there. All right, so I encourage every one of you to work on your own portfolio and build it. It's also actually good for you if you want to get a job. If you want to be a data analyst or a business analyst like me, you can say, this is what I've been doing. This is my portfolio. And people are like, okay, and then they'll be like, okay, that's cool. So it's also a good way to learn from others. They mostly use ggplots and they're very good visualizations. I haven't actually started one yet, but I think I'm gonna start next week. So if you have the time, you can go on Twitter and look for hashtag Tidy Tuesday and see what everyone else has been working on. So this presentation is actually like, I'd say a follow-up to a webinar I did last year for the Code Data Connect webinar series for early career researchers. But it mostly looked at the importance of data cleaning. So we looked at the quality and the standard and some real life examples of how you can incorporate and how you can use data cleaning and why you need to use it. So you can, I think the link is there on GitHub. So it's actually also important. It's at a very basic level for you to understand data cleaning. And then this could be I wouldn't say advanced, but this is the practical side of the data cleaning. The packages we'll be looking at are stated Janitor, Narnia, Amelia, Data Wizard, as well as DataTable. I think, like Paula said, all the packages were there in GitHub. You can install them in RStudio. And I think there's a poll that is going, I don't know if it came out, I didn't see, to see whether
Yes, let's do the poll now.
Okay,
yes.
Yeah, we can do the poll now. So we could good if you can also mention, okay, here we are. Where we go to user. Paula, do I need to fill out the poll or should I continue?
If you want to.
Should we wait for everyone to fill out the poll so we can wait for 5 minutes? So
yeah, we'll just wait. I see how many people have answered. So half of the people already answer. And
okay.
If you see the poll, it's asking you whether you've used any of these packages. And that will help us also adapt the time of the demos.
Oh, okay. So the package.
Sorry, I haven't put a non option, but that's all right.
Oh, okay.
If you haven't used any, then you can just leave it.
So
okay, so I'll end the poll and I'll show you the results. You can also see.
All right. Okay.
Is everyone able to see the results or just the hosts?
I can see the result.
Okay.
It looks as most people have heard of or used Janitor and DataTable, which is cool. Yeah. Is this that, have you used, okay, have you used, all right.
Yeah.
All right. Okay, that's cool.
So I'll stop sharing the poll now and you can continue. Thank you.
All right. Thanks, Paul, and thank you for everyone for filling out that poll. So it's good that we've heard of most of these, of the packages. And the packages that we're talking about today are not inclusive. You don't only use them for data cleaning, and they're not the only ones that are used for data cleaning. There are some such as Outlier, and there's Robust HD, but the thing is that they only have very few functions. So that's why I wanted to talk about these packages, because you can use them in your project work a lot. The Janitor package, which is it seems as though it's the most common and the most popular. I've seen a lot of other webinars use the Janitor package. It's actually used for examining and cleaning data. It was developed by a man called Simon Firk. It's actually beginner and intermediate user-friendly. And the main functions could be used for cleaning the column names. You can see the frequencies of the column, as in the tabulations, the summaries. You can see the mean, the standard deviation, your Z-score, as well as the average of your column. And it can also be used for looking for duplications. And there are also functions that are called adorn functions that are used to format your tabulations to make them easier to read. So you can change them to percentage, you can change the decimal, you can change them how you want to actually see your summary. And there's a good vignette online to see all the functions and how they work. And the interactive demo we'll be using for Janitor, they're not going to be looking at all the functions, just some of them to help you see what you can use Janitor for. Another package called Narnia was actually developed by an Australian. I don't know if he's an Australian. I think about the name, his surname spelling wrong. Sorry about that. But yeah, it was developed by an Australian called Nick Tierney, and I think he worked with Di Cook. I think I spoke to her some time ago, but I haven't heard from her in a while. Right, so it's used for handling missing values. And if you look at the name, if you look at the word Narnia, you can see it's NA, which is missing values in R. It's clever, isn't it? Right. So it's actually the word is clever play on words. So Narnia is used to inspect and visualize the pattern of missing values and to get some insight from the summaries and manipulating the data frame. So the data structures used in Narnia are used to observe the non-missing values as well as the missing values in parallel, which is called binding shadows. So what they do is that you have a matrix. So on one side of the table, you have your missing values, and on the other side, just next to them, you have your non-missing values. Did I skip? We talked about Janitor, we talked about Narnia. Right, and when we do talk about missing values, you can't help but talk about imputations. So imputations are replacing those missing values. And so what Amelia does, what Amelia package does, it looks at the analysis of the multiple imputations. So multiple imputations is you're creating multiple data sets, multiple imputed data sets. So you're creating multiple data sets of imputed values of from the missing data set. I hope we all understand what I'm saying. And it's also the Amelia package the name comes from Amelia Earhart, the lady who traveled the Atlantic. I think she was the first lady who traveled the Atlantic in the 30s, a long time ago. And she actually unfortunately disappeared. I personally think she landed on the island and she lived out the rest of her days there. Anyway, the Amelia package uses the joint modeling, which is the normal distribution. So the normal distribution is actually you create a model and then you use it on multiple data sets. And there's a function in Amelia, which is called Amelia, which uses the bootstrap, which is a resampling algorithm, and it uses the expectation maximum algorithm, which is a maximum likelihood based model. We're not going to look into it, but if we're not going to look too much into it, it's not too complicated. It's just how can I say it? It's basically imputation, replacing missing values in a data set. And there's actually a cool study by Katrin Nguyen John, Colin, and Catherine Lee, who talk about the modeling, who talk about the analysis in multiple imputations. So if you have time, you can check it out. We can move now, moving on to DataTable, which is another common package everyone has looked at, which was written by Matt Doyle from 2008. I don't know if anyone has used it. So DataTable is actually an alternative version to DataFrame. It's also very fast. You can use it very quickly on tabular data, but not only used for tabular data. It's incredibly fast. It has many features that DataFrame doesn't have. And if you look at the syntax for DataTable, you have your I, which stands for the where, you have your J for the column, and you have your group by. So it's actually the same as, not the same, but it comes from the SQL syntax. So one of the features that DataTable has is the binary search. So you can work on the binary search using the keys, the key concept that we'll be looking at later. So all the narrative and what are they? All the how can I call it? What can I say they are? The research or the functions or further explanations of how you use them. You can find them in the GitHub. So for those of you who don't know what binary search is, it's a type of search that you can use on an ordered data set. So on top here, we can see a list here, an array here is from 1 to 9. From 1 to 9. So what the search does, the binary search does, it works on an ordered table. Let's say that you want to look for the value 6 in the table. So what you do is you go in the middle of the list, you go in the middle of the array, and you see if the value matches your target value. If it doesn't, then you can say whether, you can look at whether the value that you found is less than or more than. If you can see then it's less than, then you have to go to the other half that's more than the target, that's more than the actual value that you found. And that other half that you've created, you divide it in half, and then you go right in the middle, and then you see whether that value found is less than or more than the value you're looking for. If it's more than, if it's depending on whether it's more or less, you go to that certain part of the list. In this case, it's more than, then you can only go left or right. And in this case, it's less than. So you have to go to the part that's less than, and which happens to be the exact value. And that's how the binary search works. I hope we all understand. It's actually faster to use binary search than the linear model, because with the linear model, you have to search everywhere and it takes a long time. So that's why the binary search is much better. Well, it's much faster, let me not say. Don't want to offend anyone who likes using data frames. The next package is the Data Wizard. So the Data Wizard is a lightweight package. I would say it has everything. You can work on your text, you can work on your visualization, and you can also work on your standardizing. When you want to work on standardizing your data sets, like if you want to find your Z-score, your standard deviation, if you want to Winsorize, you can Winsorize a certain column, and you can Winsorize the whole data set. So Winsorizing is limiting the results of you're limiting the results of your analysis by reducing the extreme outliers. So outliers are those values that are far out away from your main results within a data set. And so you can also perform easy transformations, and you can basically use it for cleaning your data. There's a good website that shows all the functions that you can use from the Data Wizard. So if there aren't any questions right now, it's good to get questions while we're talking, but it's always best to ask at the end, because your question might be answered during the talk. So as Paula said, I hope you have your packages all installed. We actually have some extra packages dplyr, reader, and ggplot2 that we'll be using for extra functionality. So let me open my RStudio. I'm going to stop sharing for a second and open my RStudio. I hope we all found the scripts in GitHub. So just waiting for my RStudio to open. Gosh. Let me just wait a little bit. Okay, now it's opening. Okay, let me just see if it's open. Excuse me.
Yeah, that gives time for people also to open the RStudio and
Yeah,
prepare.
open this. That's right.
If you are familiar with projects, this is a good time to start a new project. And you can download the CSV file and the R scripts from the GitHub link.
Okay, my RStudio is still loading. Let me share my screen. This. Yeah. Okay, can we all see my RStudio? Is it open?
Yes.
All right, so we're going to be working on our packages together. So what we can do is let's open the project. So opening the project where all the scripts are, as well as the CSV file is. And once it's opened, it should be loaded. Close this one. That seems to be open. Let me open it again. Okay, let me just close my. Okay, it's opening. Okay, I should have opened it before.
Yeah, that's all right. Well, while it starts, maybe you can start describing the data set.
Okay, so for those of you who've opened or seen the data set, it's about buying and selling houses in a certain area. So we have, it has the name of the people, so the landlords and landladies, and it shows the price, the year it was built, as well as the actual location of the house, as in it shows the neighborhood, and it also shows the description of how the property is. Start with step 1, using the Janitor package. It's all right if we don't do it if you don't do it at the same time, because you can do it at a later time at your free time. So starting with opening the packages, we have Amelia for imputation, multiple imputation analysis. We go to open up our Narnia DataTable. So we have a code up here and we have the output at the bottom. I'm just going to open it up. But what I think I'm going to do is I'm going to close my camera because I think that's slowing things down. Right. Where did we stop? Data table. Okay. We're going to move on to Data Wizard. I'm going to open the library, open readr. That was to use ggplot and dplyr. So you have to have these packages already installed. If you don't have them, you have to first install them and then use the library to open them up. So the reason why we have dplyr is because we want to use the pipe function. Right, now that everything is open, we're going to be using the readr package to read the data set. So we're going to give it assign it to HP. We're going to give it a name. Then the readr underscore CSV. In fact, I should have put readr here. Okay. Right. I'm gonna add that later and update it in GitHub. So using the readr package, readr underscore CSV statement, it reads the data set, the CSV file. And if you want to take a look at it, it opens up. Well, it should be opening up soon. Oh, let me save it here. Let me just see if it's ready. Doesn't seem to be opening. I don't know if it's frozen or it's just not.
It's still running.
Okay, it's still running. Okay. I guess we'll just wait for it to. My R Studio is pretty slow today. Not sure why. I don't know if I need to close of
We can try stopping that.
okay.
In the
Stop
console,
it.
you see that red, that
Yeah,
red button
okay.
to stop, and then we'll run that line again. If that doesn't work, maybe we need to restart our studio.
Yeah, we have to restart us. I think so. Okay. Okay, we'll just restart it. Let me just close everything else. Everything else that's open. Okay. Let me share my screen again. This time it should work.
Yes, we can see your art studio.
Okay.
The project needs to be reloaded.
Yeah. Let me open again. Still loading. Hey, Paula, if you have the scripts, do you think we could use your R Studio? Is that okay? Then I can go through it.
I'll need a second.
Okay. Okay. Let me see if this will behave now. Loading Amelia. Loading Narnia. This time I think I'm just going to let every statement take its time running. Janitor, read R. Okay. We have our ggplot 2 and dply for the pipe. This is where we stopped. Well, this is where we were starting. Now we assign the data setting to HP. After reading it, there we go. Right. So after reading it, we see from the data set we have 50 rows and 17 columns. Let me just close my video and close the camera. Right. And it also shows us that we have 5 characters and 12 doubles as the data type. So the reason why I wanted to use the readr function was because it actually shows in detail the number of columns in the rows and the data types that are there. But the janitor has a read function, which is called, let me write it here. It's called read. You can also try it out after you've installed Janitor. So now that we've opened our package and we're reading it, we see what it's about. We can actually open it. Let's view our data set. It should open at the top. I hope we can all see it. Can you see it, Paula?
Yes,
Right.
I can see.
So looking at the data set, it shows us the ID. So it looks as though it's already indexed. It has its description of the property, the host ID of the host, as in the landlord or the landlady, the neighborhood where it's from, Manhattan, Harlem, Murray Hill. It looks as though this property is actually from New York. It also shows the points where they're located. So these latitude and longitude are, I think they're for the geospatial mapping. We're not going to cover that today because we're mostly focusing on the data cleaning. It also shows the room type for every the property, the house price, the minimum nights that have been stated, or if they are renting, those are the minimum nights. So it looks as though it has some missing values that we're going to work on a bit later. It has the availability in a year built, and the year it was remodeled. So now that we've seen our data, we have to think of, okay, what can we do? All right, we can see that we don't really need latitude and longitude. So what we can do is we can remove it. And the data wizard has a remove column function. Well, it's actually called data remove. So we're going to be using the same data set so we can see every change that we've made. So every line, every statement is going to overwrite the previous one, so we can see all the changes. Now that we don't want latitude and longitude, we can remove them using the data wizard package data underscore remove function, and we state our data set that we want to use and the column name, and we run it. Okay, that shows that it's gone. Let's just take a look at it. So when we go back to it, it will automatically load, and we can, where is it? Oh, and then we can see that the latitude column has been removed. And if we want to remove any more, let's remove the longitude as well as the ID. We're going to remove the ID because we can see there are actually 2 indexes. There's the ID for each row, and there's the ID for each landlord or landlady. But let's keep host ID and remove the ID column. You can remove the ID column, and let's take a look at it. After loading, we can see the latitude and longitude and ID have been removed, which is cool. Now that they've been removed, we can try and change the order of the columns. We don't want the name or the description in front of the host ID. So what we can do is we can change the order using the data order or data relocate function under data wizard. And by writing that, we type in the data set and we mention the columns that we want. So first we have to write the name of the column we want ahead of the column we want to put it before. So after running that, if we go back to the data set, we can see that it's actually moved. It's moved to the right side of the host ID. And if we want to make any more changes, we can move the host name in front of the name, and let's see what it shows. Oh, but now it shows that the host ID is after the name. So in order to change that, we can, in our statement, we can move host ID in front of the host name, like so. There, and we've just reordered our columns. So if we look at our names, well, if we look at the names of the columns, we can see they're all standardized, they're all in order, they're all okay, but except for the last two, we have the first letters are all in capital. And this is where we use our janitor clean names, which is the most, I think, the most common function that we know of. So we use the clean names for janitor, and we just put in the name of the data set, or we can put the column. But just to make sure everything is standardized, we put in the whole data set, and going back to it, we can see that they've been changed, which is good. If you want to change other column names, such as price, for example, we want to change it to house price to be specific. Even though janitor has a function for it, we're going to use the data rename function. Data rename for to change the price into house price. And after running it, it will automatically change it. And we have our price to house price, which is good. Everything's looking good so far. So now that we've changed everything, we've changed the names and we've reordered the columns, we want to see if there are any duplications, which is also one of the major functions from janitor. So we use the get dupes, we get the name of the table, and we want to check all the columns. And the message at the bottom is showing us that no duplicate combinations could be found in all of the columns, which is good. So now that there are no duplications, we can get to see tabulation. We can get to see a summary of each column. So let's take the host name, for example. So under the host name, it shows us the name of every landlord that's in the table, and it shows us the number of times that the host or the landlord or landlady appears, and the percentage amount of time that they appear. So in the statement here, we use the table function, and we used the host name. In order to get the percentage, we use the adorn percentage format in order for us to see it as a percentage, because otherwise it would be as a fraction. So we use the digit to 0 so that we don't have any decimals, and it allows us to show it as a whole. If we want to also see the different range, if we want to see the highest range of, let's say, a house price, the middle range of the house price, and the largest, we can use the top levels. We can use as factor house price. And we also use the adorn percentage format again. If we run it, we can see at the bottom here, our output shows the lowest house prices, which is 40,000 to 90,000. And there's another one. And this is the amount of time. This is the amount of, not time, the amount of times that they show, which is 11%. And we have our middle group, which takes the majority of the data set, as well as the highest range, which is from 279,500 to, I think, 319,000, which is also 11% of the time. Now that we've cleaned it up and we've also changed the structure, we can move on to the second step. Which is handling missing data. So if you want to check if there are any missing data, we can use the Narnia, anything that's missing. They say, yes, it's telling us that there is something that's missing. And we ask what exactly missing, what exactly is missing, where is it coming from? And it shows us a frequency table. So the miss_var_ summary shows us the missing values for every column. So it shows us the column exactly where our missing values are coming from. It shows us the amount of missing values they are and the percentage as well from the data table. So if we want to see it, if we want to plot it, let me just move it at the side here. So we can make our plot give us some space. We can use _miss_variable. If we run it, no, this warning message is just telling us that there's a feature that needs to be updated in the statement, but otherwise it doesn't affect the plot at all. So looking on the right side, we see that the most amount of missing values come from the year remodeled edition, followed by review per page, and there aren't any missing values for room type, host name, and the other columns. So this is another visualization if you want to see it. And another way we can see, if we want to see the relationship of the missing values, like where exactly what is the relationship between these missing values between columns? We run the gg_miss_upset, and we order by the frequency. We run it there. Another graph will pop up. And in this graph, it shows us that the year built missing variable has 3 missing values. And looking at this graph, it shows us that it shows the number of missing values that are there. So looking at the sixth time the number of times the missing values are missing belongs to the year model, as we saw in the table. And also the next one, house price, year built, as well as minimum nights and reviews per month. And the line that's matching the dots shows the relationship between the records where the missing values are. So if we look at minimum nights and review per month, we can go back to the table. Let me just open this up so we can see the table properly. The age. What we want to see is minimum nights and review per month. If we order it nicely like that, and we look for where the missing values are the same. See missing values. There we go. So for this plot shows us that there are 2 missing values for minimum nights and reviews per month. So here it shows us that where they're both missing at the same records. So this is how it shows us the relationship between missing values between some columns. And it's also the same for review per month as well as the year remodeled. If we can just quickly take a look at it. Reviews per month and reviews per modeled, we can see where they're both missing at there. Here we go. We can see that they're both missing at the same record. So this is what the plot is showing us. If we want to see a categorical variable, we can just use this statement to build a plot using the geom_miss point and using the facet in order to show our categorical variable. If we run it, we take some time running. It shows us, if you can see it, it's just appeared right now. It shows us based on the year built and the year remodeled, based on another column called the calculated host listing count. It shows us the amount of values that are not missing, as well as the ones that are. So right now there are missing values based on the year built and the year remodeled. Now that we have our missing values, we can try and see whether an imputation can work. So before we impute, we need to change the HP as a data table for now, just because we want to use a data table in order for us to analyze the data. So we change it to, we actually force it, the data frame, to a data table using the data table package. That's fine. And then now that we have our data table, we can actually drop the columns. By dropping, we have to assign it to a particular table by removing the following columns: name, host name, all the way to room type. You can run that. And now that we have our dropped columns, we can assign that to another variable. We use the data table. We assign the columns that were dropped from before, and we assign that to that table. And now using the Amelia function, this is where we start to impute the missing values using 5 data sets. So that's why it's 5 at the end. So using the Amelia function, we're going to assign it to res.amelia. Like so, and at the bottom here, it shows us 5 data sets which have imputed the missing values as well as the observed values. So with that, we can try and see, now that we have our imputed values, we're going to try and visualize it using the compare density, using a particular column. Let's use house price. So what we have here is, it shows us a density plot of the mean imputations as well as the observed values. So looking at it, it shows us that I think because the table doesn't have a lot of missing values, it doesn't show a large imputation. But if we try and increase it, like so, if we change it to like 9, we run it. We've increased the data set and we run it again. We can see it's changed a little bit. We can see that the observed values are skewed a little bit to the left, and the mean imputation is a little bit symmetrical with a dent in the middle. So this kind of tells us that it helps us to see whether we should impute further, or we can just test if this is the right imputation to use. If we want to further analyze a little bit more, we can use a cross-validation or the over-impute function in Narnia, but because of time, maybe we'll do that another time. So we can continue from this, based on this analysis, we can either continue with imputations, but I say we can, because in rule of thumb, if you have 10% missing values, then your analysis is going to be biased. But if 40% of your missing values are 40% more, then it's just a hypothesis it's just a hypothesis analysis that you'll be creating. So after that analysis, we can go on and impute our values using the impute mean. So we're going to be imputing all the missing values that are numeric. And if we go to the data set, we can see that the missing values should be covered. We don't see them. Yeah. There we go. All the missing values have been imputed based on the mean. And the reason why it shows I think we have a question. Lonnie, can we take your question or should we take it later? We have a hand up, or is that a mistake?
And she has a question.
Okay.
Hi, no, my question is what you just said about the missing values. You were saying something about if it's 10% and if it's 40%, it's a hypothesis. Can you please go over that again? Because I didn't quite understand.
Oh, okay. What I meant was after looking at the imputed data, I was saying that if you look at your data and you see that 10% of the data, if you see that the missing values are 10% more, if 10% of your data is missing, then it's bias. It's going to be, your analysis is going to be a bias analysis. It's going to be lean towards a specific side. But if your missing values are like 40% of the whole data set, then it's going to be referred to as a hypothesis gathering. Like it's an educated guess. Yeah, that's what I mean by the 10% of your data set being missing and your 40% of your data set being missing. Is that okay, Lon? All right, thank you. Thank you for that. Right. After imputing our missing values, we're going to check again if there aren't any more missing values. Oh, and it tells us there aren't any. So we can save that script and we can move on to the very last part of our data cleaning, which uses the data table. So this is the part where we change our data frame into a data table. Now, the difference between a data table and a data frame is that a data table is it's an updated version of a data frame. And with a data table, you can do a lot more things. As I said before, there are a lot more features like the binary features, and it's a lot faster than your regular data frame. So for here, we're going to we don't want to say force, we're going to change the data set to a data table using the as.data.table function, and we're going to view it automatically. So we don't have to write it again, and then we're going to have to view it. So if we open it up, we can see it's automatically been created into a data table. You can see it looks just like the data frame, but this is actually a data table. So from there, we're going to see what data type is it? And at the bottom, it shows us it's a data table and a data frame, which we want. So to show you what we can do with data table, we can actually select the rows based on what kind of variable that we want. We can open it up, data table, and instead of using the curly brackets, we'll use a square bracket. Then we write the column, and in the column, we want the private room variable plus the house price, which is more than 180, 100,500. And the 4 shows us just the first 4 top results. So if we run it, it shows us the results at the bottom. Let me just pull it some more. There we go. There we go. And it actually shows us our top 4. And here it shows our private room records and the house price, which is actually more than what we want, actually more than 180,000. And if we want to have a specific column, what we do is we put in a comma to show that our row is empty, so we're not specifying the row, and we can list using the dot open bracket, list the host ID, host name, and the name, and we show the first 4 results. And it gives us the host ID, host name, and the name for the first 4 results. And if we want to see the records based on a specific record and the columns exactly, we have, like what we did in the beginning, we put in our neighborhood, we specify a neighborhood and the columns that we want to see, showing the top 4 results. And we have it here at the bottom. So that's pretty cool. Another feature, what I didn't talk about was the syntax for the data table. We have our open bracket, our square bracket. We have our I, which represents the, it's in capital. We have our I, which represents our rows where we want to look for, our columns, as well as the by. So this is the same as the SQL, but doesn't necessarily work just like SQL. So from here, we're going to be using the by, the grouping using the by. So in this refers to categorical variables. That is, it puts the variable on the basis of which the grouping should be executed. So let's say if you have 10 types, if you have a column, right, and you have 10 types of paint colors, you have turquoise, you have aquamarine, you have violet, red, pink, blue. For a table, you can say that you want to see only the rows that are pink. So all the rows that are pink are going to show. It's not the same as showing the rows, but with the by, you can actually use it like, can I say, you can actually just specify the pink exactly, because with the rows, it doesn't always show the pink records, the pink paints that are quoted. So with that, you can leave the row empty and you can specify the columns. And this time we're going to be using the mean price. With the mean price, we're going to use house price and we're going to label it mean underscore price, looking for the mean of the house price by the neighborhood. And we're going to show the top 10 results. Oh, and from that, we're going to assign it the chain gang, and we're going to just see the top few records. So from here, it shows us the mean price for a particular neighborhood. We can see the mean price for every neighborhood there using the grouping using by. And also another feature that you can do with DataTable is the chaining. So the chaining is you can put in as many statements as you can within the square brackets. Here we have the head. That's why it actually shows brackets. But for here, you can write a long statement, but you can always put them together as long as they're in the square brackets here. Sorry about that. So for here we have, let's say we want to see the amount, we want to see the full list of the maximum house price based on the neighborhood. And we're also going to see another column showing the minimum price of the house price. And we're going to round it up to 2. If we run that, we see our top 4 results. We have our count of a maximum and minimum. This actually states that there are two, let's say for Clinton Hill, there are two properties that are the same house price and actually the same, which has the same minimum house price. Moving on to another feature for binary, which is the binary search. It actually uses a key. So the key concept in the data table automatically orders and sorts your table based on the key you're going to use. Like for instance, we can use the host ID as the key, but we won't. We're going to be using another key just so we can index it. We can order the table by that column. So for line 17, we're going to set the key to neighborhood using the set key function. And if we run it, it's already set the key automatically. And if you want to see a key for a data table, we can use the key function and it shows us that the key is the neighborhood. So the whole data table is based on the neighborhood column. And if we want to select a row by that key, we don't have to put in the data table and then mention the column. We can just put in the name of the variable under the specific column, and we want to show the top 3 results. And it shows us, the results of the records that are under Harlem based on the neighborhood key. And if you want to see the column as well based on the key concept, we can assign it to room by neighborhood, assign it to that, and we can, let's say we use the Bedford-Stuyvesant column as well as showing the neighborhood group, the Bedford-Stuyvesant row it shows us that row and it shows us the columns that it's going to show us. So now that it's been assigned, we can just see the results of it. And it shows us on the statement, we have our neighborhood group, neighborhood, and the room type. And the final feature that we're going to look at is the group using key by. So for here, this is the same as using the group by, but instead there's a key that we're going to be assigned to it. So we're going to assign this to a value name, and then we want to see the rows that are Hell's Kitchen, and then we have our neighborhood as well as seeing our number of views. And we're going to key by availability. We're going to key by the column availability underscore 365, and we're going to show the top 4 results. So the difference with the key by, as we can see here, it shows us the availability by the availability of in the year, the neighborhood, and the maximum review. The difference is with this, it automatically changes the key of this particular data table that we created. So if you want to, let me just write it and just type it here. If you want to see the key for this, sorry about that. If you want to see the key for what we just created, it will tell you that it's availability underscore 365. But the key for the data set is still going to be neighborhood. Right. So I just want to show you one final function, and then I promise I'll be done. Let's say if you want to join two different data tables. If you want to join two different data tables that we just created here, what we can say is we can assign it. Let's say typing. Say final, because this is the end of our script, and we can say, we can use the merge data table, and looking at the top, we can use, which ones can we use? We can use the tables that we just created, which are where are they? You can say average and average, right? And then again. Those are the two data tables that we just created if we want to merge them and put them together. And if we run it, it has created it. So if we want to take a look at it, let's say, let's run it like that. It shows us that we've just combined the two data tables that we created, average as well as Chingan. Yeah, so I think that's end of the demonstration. Didn't mean to take too long. Thank you for staying until the end. You guys have been very good today.
Thank you.
For that. Thank you for being so patient as well with my RStudio misbehaving. So because we have
a question, Simi.
Yeah.
Could you go over like the dot notation in the table using the data.table, like you have like for the line around line 14 where you make your average data frame, it's like you have the HP underscore DT. Then the comma you said is because you don't want to do rows, like just the normal rows, columns, indexing. But then what's the dot after that again?
Okay, let me just go back and see. Can we all see RStudio? You said line 14?
Starting slowly.
Okay.
Yeah, so around like line 10, I guess, like, or all of them have like the dot, but you have, you know, the square bracket, then the comma, but then you have a dot. Like, what does the dot mean again?
You mean here? Which one? You mean this side here? You mean after the dot, it's a dot and an N?
Just in general, like, I guess both of them. Is dot N, is that a
dot N,
variable?
dot N shows it's like a count. It shows the,
okay. Number of observations.
Okay. The number, yes. And this dot here, the dots and the brackets here, this is a list. It indicates a list of columns that you want to show.
So kind of like C, but like data frame.
Yes.
Syntax. Okay.
Yeah.
It. All right. Yeah, I've familiar that it's data table is a little bit different, but I haven't actually used it. So okay.
Yeah,
awesome.
right.
Thank you.
Okay. All right. Thank you for that question, Catherine. Okay, so we've come to the end of the talk as well as the demo. Thank you so much. You can find Our Ladies Gaborone and Meetup. We have a few videos that we've talked about. As I said, that the chapter is still very new, so we don't have that many videos. And you can also get the scripts and everything we've done in the GitHub, as well as in Our Ladies Brisbane. Thank you so much, Our Ladies Brisbane. You girls you really know what you're talking about. You really know a lot about and I've learned a lot from you.
Thank you, Simi, for your time. Your presentation was excellent. We enjoyed the demo. Thanks for providing the code. Yeah, we have all the links available through the link that I just shared, and we will let you know when the recording is ready. If there's any questions, please ask now, or we have a little bit of time just to network. We are growing. Today I checked, we have 700 plus members in the meetup page, which is amazing. Letting you know that this is the start of our 4th year. So we just had our anniversary. And this is my last presentation as well as a co-host. I founded Our Ladies in 2019, but now we have other co-hosts who are willing to take this further. Those are Catherine and Valentine and Katie and Retta. The last two I think are not here, but you will hear from them via the meetup. Yeah, any comments? A lot of thank yous for you, Simi, and I joined those.
Right, if there aren't any questions, I just want to talk about other data cleaning packages that I didn't talk about. I did say that I wanted to talk about Robust HD, which is used for outliers, as well as outlier package. But the problem with those packages is that there's only one function to sort out the outlier, and it just indicates whether there's an outlier or not. And there's no function to actually override that outlier. And there's so many, and also
they have that for the next presentation. Someone
yes,
talking about robust HR.
That's right. We need a follow-up to cover all these other packages and functions and visualizations of mapping the table that we didn't do today.
Paula, I was wondering if we have a few minutes, do you want to just show everyone where everything is on the GitHub? Like just where the slides are and things like that?
Sure.
All right, let me
A few people have asked about the slides.
So Paula can share her screen.
Okay. Okay, I'll go from the top. There is a link on the Our Ladies GitHub page, and then you can find the meetup presentations for Our Ladies Brisbane. As you can see, these are all the years where we had events, and we are in year 2022. You can also find that link from here. You'll find presentations and meetup order by the year and month. So you can have these useful links handy. This is our Twitter account. This is where you've registered the meetup account. This is the GitHub account. You can join Slack for conversations, just to ask follow-up questions or stay in touch with the community. We have also presence on Facebook. And then we have the YouTube channel. So if you go here to the events of 2022, here's where we're going to list all of the events starting in January. And this is the R package for data cleaning. When I click here, you can see the name of the speaker, Simi Namda, and the link to the meetup. And then here is the link to slides. It's a PDF. And the second link is the link to the code that is directly going to the Our Ladies Gaborone GitHub account. And then we put links for the things that are being mentioned in the slides. So the webinar, the different packages where you can install them, where you can find more information, and then the links to Our Ladies Gaborone for the connection. Yeah, I hope that's all you need, and that it's not that difficult to find. This link is also on the overview of the meetup page. Okay, I think we are just on time. If there was no more questions, thank you, everyone. Thanks for being here, and see you in the next event.
Thanks, Paula. Thanks, Catherine. We'll keep in touch, yeah?
Yes, definitely.
Definitely.
Thank you so much, Simi-Sunny. That was really great. I'm not gonna use like is.na to find a names anymore. So that's yeah, that was really useful. All those like visualizations of like, yeah, that was really cool. So thank you so much. Really appreciate it. And yeah, we'll be in touch, I guess. So have a good, I guess, day if you're in Gaborone.